Example 142. Use the data from the FCAT problem that opened this section to form a 90% confidence interval for the mean difference, the true average difference between before and after FCAT scores, and interpret the results. Okay, so what we're looking at here is the problem that we did at the start of the section for matched paired t-test or dependent t-test. And we're trying to do a confidence interval now using that same data. Now this confidence interval is going to use 90% confidence. And that is because if you look back at what we did, and I happen to have that work that we did for that hypothesis test, when you look back at that, you can see that we had an alpha there of 5%, but it was a one-tailed test. So in that one tail, 5% of the area went in. With a confidence level of 90%, the alpha is 10%. But alpha will be split into two tails in this confidence interval, so there will be 5% in each tail. And that's important because then it's going to be 5% in this side and 5% in that side. And that will make our interval analogous to what we're doing here. And so whatever conclusion we derive from this confidence interval, it should match the conclusion we found here. If you remember here, we decided to support the claim that after was greater than before, and also pay attention to how we did the subtraction back then. So we're going to take this data and we're going to form a confidence interval for this difference, basically. We'll call the interval mu d. It's an interval for the mean difference, but in reality that difference was formed by doing after minus before in the problem. So let's take this data and put it to use in our confidence interval for this problem. Okay, so writing down the data we just saw there, we have that the sample size for the differences was 8. There were 8 differences, or 8 students of data. And then we had the sample mean, and that sample mean was 11.875. And then we had the standard deviation for the differences, and that standard deviation was 3.720. So those are our 3 values. Now, because the confidence level is 90, we know that our alpha will therefore be 0.10. Okay, so there's our data. Our next step in a confidence interval is to get our critical value. It's going to be a t alpha divided by 2 value here. And specifically, it's going to be, if we're dividing alpha by 2 and alpha is 10%, it'll be a t 0.05 with 7 degrees of freedom, right? So we need to go to the table and look up 0.05 with 7 degrees of freedom. But since we've already done that back when we did the hypothesis testing, we should just be able to pull the same number, t 0.05 with 7 degrees of freedom. We can see that that number was 1.895. So we don't need to do it again. We'll just write that down, 1.895. Okay, so we have our critical t value. Our next step is going to be to take that number and put it into our margin of error formula. That margin of error formula, remember, is t equals to t alpha divided by 2, SD over the square root of ND. All right, so that's our formula. And if I plug in the numbers here, we'll have 1.895 times the standard deviation for the differences, 3.720, divided by the square root of 8, right? 8. Okay, let's enter those numbers in then and see what that gives us. So we'll have 1.895 times 3.72 divided by the square root of 8. Okay, and after doing that we get 2.49 approximately. 2.492, let's say 3. So 2.4923. Okay, that's the approximate value. I'm going to store the value that we got in our calculator though so I can use it later. So I have that value in my calculator, and let's finish it up. The last step of this is to fill in the interval now, right? And that interval, recall, is x bar for the differences minus the error, and x bar for the differences plus the error. So x bar for the differences is 11.875 minus this value I just found, 2.4923, and then do the same thing but add this time. So 11.875 plus 2.4923. Okay, now that I have that written out, let's go ahead and work it out. So 11.875 minus the error, and then the same thing but plus the error this time. and we end up with 9.38 up until 14.37. All right, now remember what this is, right? This is a confidence interval, so we're going to say we are 90% confident that the mean difference is inside, right? Inside the interval. Remember what that mean difference was, right? The mean difference for our problem, if you look back at what we did when we did that FCAT problem, that difference was after minus before, after minus before. So we're going to say the mu after minus the mu before. All right, now, when you look at the interval and you see that it's fully positive, that it's completely a positive interval, it means this number is therefore higher than this number. So based on that, we're going to say that the mean after is better than the mean before or bigger than the mean before. Now we're talking about test scores here, so the fact that this mean is higher, that's why I said it was better. So the average score after test prep was higher than the average score before test prep. So again, just like our hypothesis test showed, we're concluding that the test prep is effective because the mean, right, the mean after is greater than the mean before because we did our subtraction in that order. And that is exactly what we found with the confidence interval. Since it was completely positive, the first mean is bigger, and if the first mean is bigger, we're saying that test prep works to improve the average grade.